Alright, so sorry about the first video. Hopefully this one works. I'm going to try to go really quickly through my example of the transformation golfing project. So I'm not going to go through details about how to create your golf course because you need to be able to create that on your own. So basically after I have created the golf course and what I want to do, I've kind of thought through the different transformations I want to make sure that you are including the correct information. This can also be helpful just to give you more practice with graphing transformations. So I've got my golf ball. I decided to use a triangle so I'd be able to rotate it and translate it and everything easily. So the first thing I want to do is take it around this curved path, which in order to create a curved path, I'm going to have some type of rotation. So my first transformation is going to be some type of rotation. So I'm going to say rotate the triangle or the golf ball. Now I decided to use a 90 degrees counterclockwise rotation. So the way that I suggest doing that is I'm going to go around the origin. So I'm going to keep the origin the same. Rotating counterclockwise would be going this way. So the opposite way of the way that a clock goes. So I'm going to turn my paper once that way, 1/4 turn that way. And then what I'm going to do is basically think about this as my new X and Y axis. So now pretend this is your Y axis and pretend that this is your X axis. And you're going to figure out in relation to that change, where does the golf ball go? So if you start here in the negative X direction, it goes 1, 2, 3, 4, 5, 6. So 6 to the left. And then it goes down. That's 13. So down 13. So you're going to flip it over, and you're going to go 6 to the left, and down 13. Right there. Yep. So I'll label that one A, and that'll be A prime. I'm going to do that with all my points. So next I'll do this as B, and this is C. So for B, I go to the left 9 and down 14. So when I flip it back over, I'm going to go left 9, down 14, which looks like right there. And then the last one is C. So to get C, I go left 9 and down 12. So left 9, down 12. That would put it here. So I expect my shape to be rotated 90 degrees when I'm done. In other words, since it's kind of pointed down when I rotate it, I expect it to be pointing left or right. In this case, it's going to be pointing that way. And then I expect it to move into the other quadrant because it's going 90 degrees all the way down there. So rotate the triangle 90 degrees counterclockwise around the origin. So I'm going to include that verbal description. I'm also going to include the new coordinates. So I've got A prime, B prime, and C prime. Oh, 14. And okay, so that's just the coordinates that I came up with when I rotated it. And then I'm going to write the rule for it. So rotations, capital R, rotating 90 degrees counterclockwise, so that's positive. Remember, if you go clockwise, you can put negative 90 degrees. I'm applying that to my, either you can write the whole triangle or basically the whole coordinate plane, however you want to say that. And then I want to write what the result is. So if you look at your numbers, you can see, okay, well, it looks like the x's, or the original x swapped places. So now it's here. And the y value swapped places, but it also changed sign. So like that. So that would be the rule. Okay, so then for transformation 2, I knew that I wanted to jump over a water hazard, but I didn't want to directly do it this far away because think about it, if you're hitting a golf ball too far away, it's not as likely to go over the water very well. So I wanted to get closer to the water. So I'm just going to translate it, just slide it over to get closer to the water. And I decided to do it by 11 units. So I'm going to say translate 11 units right. So for A double prime, B double prime, C double prime, since I'm just moving to the right, I'm going to add 11 units to each of my X values, but my Y values are going to stay the same. So I could go ahead and write the rule. So I'm translating capital T in the X direction, I'm going right, so it's positive 11. Y direction, I'm not moving any. And the rule would be to add 11 to your X value and leave your Y value the same. So when I go up here to graph that, I'm going to move everything over 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Do that with all my points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And those should match the ones that I said down here as well, so you could double check that. Okay, so the last thing I want to do, or sorry, the second to last thing I want to do is jump over this water hazard. So the only way to kind of jump off of your page is to reflect over something. So I'm visualizing kind of jumping off and landing over here. So I decided to go halfway through the water hazard because I know if I figure out how far away I am from that side, I'll be the same distance away from the other side. And I think it's 5. 1, 2, 3, 4, 5. Yeah, 5 away. So I'll be 5 away on the other side. 1, 2, 3, 4, 5 for A. Triple prime. For C, I'm 5, 6, 7, 8. So 5, 6, 7, 8. B, C, triple prime. And B, triple prime. So then my rule, I said reflect over the line X equals 10, my points. Okay, so then to come up with a rule, it's a little bit tricky for this one. So I'm reflecting over the line X equals 10. But to write the rule, it took a little bit of kind of playing around with the numbers and seeing what's happened. So I noticed that the Y values stayed the same. So nothing's happening with my Y value. So I'm just going to leave that the same. But the X value does change. And I realized that what was happening is basically we're taking that number and subtracting it from 20, which has to do with the fact that this is at 10, and that's 10 spaces away from the y-axis. So you can play around with your numbers a little bit, but I realized that it was just 20 minus whatever my original value was. So 20 minus 5 is 15. 20 minus 2 is 18. 20 minus 2 is 18. So I kind of saw that pattern happening there. And then the last one, I just need to make sure that it goes in the hole. So it just needs to translate a little bit. I realized that so translate to the right 5 units would work. So a quadruple prime, I guess we could call it that. So that's the 4th time, ends up here. Because I am just adding 5 units to my x value. So then we're going to translate 5, 0, x, y. So x plus 5, y. And then move it over 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. There we go. 1, 2, 3, 4, 5. And there's my triangle, so that would be all of them. Another thing that I would suggest doing is being able to write all of these together in the correct order that you did them. So in other words, we did this one first, so if you're kind of working from the outside, oh, whoops. So if you're working from the inside out, you would say, okay, the first thing that we did was rotate 90 degrees. Then we translated 11. Then we reflected over x equals 10. Then the last thing we did was translate 5. So that would be kind of putting them all together. And you could technically write a rule for that. So if you want to be able to write your rule for that, if you want help with that, you can continue watching the video. But basically what's happening is you're following it through, not like this. So let's pretend we had any point like A and B. When we rotate at 90 degrees, the rule was to swap them and make the new x value negative. So if we swap them, we get this. Next, we take our current x value and we add 11. Next, we take 20 and we subtract this x value, the whole thing. Y stays the same. So if I subtract that whole thing, I end up with 2. Distribute that negative 1. So plus b minus 11. Simplify that, you get b minus 9. Last step, add 5. Oh, sorry, instead of y here, I should have wrote a the whole time. So I changed that to a instead of y. Okay, so anyway, what this means is that you could take any number. So like if I wanted to move this point, whatever that is, I could take negative 5 and negative 2, and I could just put the negative 5 here and the negative 2 here, and I'd have where it would end up after all those transformations. So this is kind of the overall rule once you perform all of the transformations.